I'm very excited because in this How Do I video I will show you how to use CL query objects to create nested loops in Microsoft Dynamics NAV. In this video I will show you how easy it is to use query objects to create nested loops. This pattern shows how the new query object introduced in NAV 2013 allows you to replace costly loops when inspecting data from 2 or more tables. We'll get there in 3 steps. In the first step, I will go over the different elements of this design pattern. In the second step, we will explain the steps to implement the pattern. And in the last step, I will demonstrate how this pattern is used in Dynamics NAV. Let's get started and investigate the different elements of this pattern. One of the core operations in a relational database is joining 2 or more tables. For example, you might need to extract all sales lines in the database together with information from the related sales header. This is going to require you to join the sales header and sales line tables using the number as the connecting field. And this join operation has traditionally been done in CL by using record looping. Now, when NAV 2013 introduced the new query object, it allowed us to produce a dataset which is the result of a join operation between 2 or more tables. And this simplifies the problem of finding related records in 2 tables linked through a foreign key. To accomplish this, what we need are 2 or more tables, a query object, and then we are going to create a processing code unit that will loop through the query records. Let's have a closer look here in the application where we have 2 tables, table 274, the bank account reconciliation line, and table 271, the bank account ledger entry. What we need to do is we need to join these 2 tables, and we know that the bank account number is the connecting field. So now in the second step, I'm going to explain the steps involved in this design pattern. What we need to do is we need to run the query on the connected tables. Then we need to loop through the records returned by the query. And then we need to process the records. So as you can see, we have our 2 tables here connected via the foreign key. We will create a query object that is going to join them, and then everything will be handled by the processing code unit. The solution of this design pattern is to use a query object. In this example, we see this query that is going to link the bank account reconciliation line table with the bank account ledger entry table. It's a very simple query where we start with 1 table on the top side or the left side, as we say, and below that indented the table, in this case with ledger entries or a detailed information. We'll use a foreign key between the 2 tables to create the connection. As you notice in this example, we are using 2 tables. Of course, in real life it can also be more than 2 tables. So if we are going to go for a solution using a query object, the first thing that we need to do is we need to define the query, which is going to return the full filtered join of our 2 tables. Then we need to loop through the records returned by the query object. And then for each record which is returned, decide if it represents a solution, and if yes, connect the 2 table records. If you have a look at a code example of this solution, what we need to do is we need to run our query. In this case, we can see this using the open function. Then while we are reading the results using the read function, you can then, for example, use a get to do something with the details if there are any, and we can then apply them. Very clean code, very performant, and very easy to understand. If you have a look at the solution using nested loops, then what we need to do is we need to apply the required filters on the left table. Then we need to loop through the filtered records, the results. And for each record in the filter, you need to find the connected or the related records in the right table, apply the required filters on that table, and then for each pair of records from the left and the right table, decide if they are a part of the solution and then apply them to each other. Now that we know the parts of this pattern, let's have a look in the application where the code unit has been created which really implements this pattern. So we'll see an example of the usage in real life of this pattern. In Dynamics NAV 2016, you can see there is a code unit match bank reconciliation lines, code unit 1252. In that code unit, we have our match single function, which has a purpose of matching these statement lines. And as we see in the beginning of this function, what we are going to do is we are going to run our query object. Then while we get results from the dataset from the query, we'll use them to look for any matching lines. So you see a real-life implementation of this pattern. We open the query, we run the query in which we are actually doing a nested loop, and then in the details we will play with the results. If they are connected, yes and no, process them. So the code is very clean and very easy to understand. Let's have a look of the advantages of using a query instead of two loops. First, a query of course is much faster. A query only requires one trip to the database, while if we are using multiple record variables, we are going to require many round trips to the database. A query is also very easy to scale. It's scalable, and we can reuse its definition by applying filters or when looping through the dataset. It's also very easy to add more fields in our query object and to add more tables, while if we're doing this with record variables, creating the loops in a code unit is going to be more complex and time consuming. Using a query only requires one loop in our code unit, independently of the number of tables in the query object. Queries are very easy to create and maintain, and also in general they will provide a much cleaner design. There are also a few ideas for improvement. We could change the query object to allow the passing of parameters at runtime, or we can build the query dynamically at runtime. The advantage would be that we will remove the need for multiple static definitions of the same query based on a slightly different context. Let's have a look at the steps that we went through in this design pattern. First, I explained the different elements of the design pattern. In step 2, we had a look at the different steps and how to create the pattern. And in the last step, I demonstrated where this pattern is used in the application. So in this video, I covered the following topics using CL query objects instead of nested loops. To learn more, please visit the following resources. Thanks for following this short video to explain how to use query objects to create nested loops in Microsoft Dynamics NAV. This video in the How Do I series for Microsoft Dynamics NAV is brought to you by Microsoft and Platan. See you in another one.